When working with circles, one thing we have to really investigate is the relationship between circles and lines given within their environment. What we're going to look at in this video is we're going to determine the intersection of a line and a circle, how we can calculate this, and just how this can come up and how it can come into play. Imagine I give you a circle. So this is just a generic circle. It's got a point C, which is A, B at its centre. Now remember, for any circle like that, there's my radius there. I can use this to determine the equation of the circle just as we've done every other question in the past. So it's x minus a squared plus y minus b squared equals r squared. We know that's the equation of our circle. Now, what we want to do is imagine I give you a generic line with its equation y equals mx plus c. I want you to find the relationship between that line and this circle. Well, there are three possible ways this can happen. First things first, I could just draw you a generic straight line like that. Doesn't intersect at all. That could be anywhere outside here. I can draw any amount of lines that have that coordination. It won't touch it anywhere at all. The second type is where it touches it at just one point on the edge. So it does something like that, skims off the edge if you like. This is called the tangent to a circle. Now in this video we're going to look how to show something's a tangent. I've got another video after this that shows you how we can use this. The third way it can do it is if it's just in slightly from that, it cuts the circle at 2 points. So it can cut through it here and here for this line. So I could do any number of lines. I could do one going like this. Doesn't matter how many I do through the circle, it will always cut it at 2 points if it's this way. Now, there's a set of steps we should really follow any time we're asked to do this sort of thing, and any time we're going to see whether a line is outside the circle, a tangent to the circle, or cuts it in two places. When we're doing it, follow these 4 steps each time. Step 1, get the formula for the equation of the straight line, put it in the form y equals mx plus c. This is a key part. If you do y equals mx plus c, we can do the next couple of bits fairly straightforward. Now sometimes you're given the straight line equation, sometimes you're not. We know how to calculate that by now. Think back to Unit 1. Second step we do is substitute this equation into the circle equation. So you know it's x minus a squared plus y minus b squared equals r squared. We substitute that in for y. What we'll end up doing is getting an equation with only x variables in it. So we've taken it down to having 2 variables within that equation to having 1. Once we've done that, third step of get the equation into this form, get it into a quadratic form. If we have it in that form, what we can then do is do the final step, which is calculate the determinant of the equation. Now, calculating the determinant is a key factor here. It's the key thing we have to be able to do, because if we do that, it'll tell us which of the 3 scenarios we're going to come up against. If b squared minus 4ac is bigger than 0, we get 2 roots to the equation. So there's 2 possible solutions within it. What that means, there are 2 points of intersection of our line in the circle, so it looks something like this. You get 2 points and the line cuts through the circle at any of these points. The second one is, imagine we take b squared minus 4ac equal to 0. Think back to when we did quadratics. That means that there's 1 repeated root to the equation. So there's 1 intersection point, i.e. 1 point where the line touches the circle. So it looks something like this. It'll touch at that point there. It's a tangent to the circle. And the last one, if b squared minus 4ac is less than 0, if we think back again to quadratics, there were no roots to the equation here, which meant there's no intersection points. So it would be a scenario like this. It's outside the circle. It doesn't touch the circle in any way, shape, or form. We have to remember each of these. If you don't remember this, I suggest you go back to National 5 stuff and think about how you do it. This is the key thing we need to remember. Now we've got the full quadratic formula, your negative b plus or minus square root of b squared minus 4ac over 2a. This is the key part that we have to focus on and look at. The b squared minus 4ac, the determinant of the equation. Let's have a look at how we could do this in a couple of examples. Find the points of intersection of the line y equals 2x minus 1 and the circle x squared plus y squared minus 3x minus 4y plus 5 equals 0. Now, step 1 was to get the equation in the form y equals mx plus c. We've got that already. Second step was to substitute this into here. So we've got it for y, put it into the equation. So I get x squared plus 2x minus 1, all squared, take away 3x, take away 4, bracket 2x minus 1, plus 5 equals 0. So now that I've got this, I can multiply out the brackets and get it in the quadratic form that I want. So I've got x squared here, multiply this bracket out, I get plus 4x squared minus 4x plus 1, take away 3x, minus 8x, plus 4, plus 5 equal to 0. Get all the terms that are the same together, so my x squares, my x's and my numbers. I get 5x squared minus 4x minus 3x minus 8x, so minus 4x minus 3x is negative 7, minus 8x is negative 15x. I've then got plus 1, plus 4, plus 5, plus 10 equals 0. Now the next step from this was to use our determinant. So the next step from this was to use b squared minus 4ac and see what we get. Remember the three possible outcomes, we have to use it. Now a was the 5, b was the negative 15 and c was the 10. Plug all of that in, I get negative 15 squared, take away 4 times 5 times 10. Negative 15 squared is 225, take away, well, 4 5s are 20, times it by 10 is 200, and I get 25. So I get a positive value for my determinant, which means that I get 2 points of intersection for this equation. So I get 2 points of intersection of the line with the circle. Now I have to calculate them. So to do that, factorize the equation. So 5 bracket x minus 2, x minus 1. That's what you get when you factorize it, and that equals 0. Using this, I get two possible answers, x equals 1 or x equals 2. Then substitute them back into here and I get the y part of the coordinate. So if I put x equal to 1 in, I get y equal to 2 times 1, which is 2, take away 1. So I know that y is equal to 1. And if I take x equal to 2, I get 2 2s are 4, take away 1, so y equals 3. What I can then say, find some of my points of intersection are given by 1, 1 or 2, 3. So I've got 2 points of intersection, there's the coordinates of those 2 points. Same set of steps, get the equation, substitute in, get in the formula, use my determinant to figure out what they are, and if need be at that point, figure out what the actual coordinates of the point are. The biggest thing you have to make sure you remember is the 3 possible ways you can get a result when you're using the determinant. So if it's bigger than 0, 2 points, equal to 0, you get a tangent, less than 0, the line doesn't touch the circle at all, and it's just a line in space around the circle.